In this notebook, we'll explore the concepts that we have introduced in the lecture on the compositional tools included in the Music Network library. So we will talk about, we will work mainly with the primitives of music, where the primitives of music here, we just consider rests and notes. So as we saw in the lecture, there are various Python objects, Python classes that we can use to define these primitives of music. And we start with the simple one, that is a rest. So a rest is a silence of a given duration and is very simply defined by this class rest that takes one argument, that is the duration of the rest itself. The rest is a very simple class that has only one method that is stretch duration, that allows us to elongate or decrease the value of the rest within, say, a given melody. Now, the most important, if you want, object here is the note. The note object. Note object accepts up to, I think, 5 arguments, as you can see in the PowerPoint of the lecture. Here we just use the 3 main ones that are the pitch in pitch class. That means a number between 0 and 11. A number that corresponds to the octave, the second argument, where number 5 corresponds to the central octave of a piano keyboard. And then the duration of the note that here is 1/4. So the object note accepts many different methods that can operate on it. And again, there is a list of this in the PowerPoint of the lecture. We just look at a few of them, and most importantly, the fact that you can input a note using different techniques. So you can use numbers, you can use MIDI numbers, you can use names. So in this first cell here, we are just using the pitch class 1, that corresponds to the C sharp, an octave 3, that is 2 octaves below the central C of the keyboard, and the duration of 1/4. Same thing we could do also with using MIDI numbers. So in this case, C sharp of the central octave here is 61, and corresponds to this information on the that you can input directly in the note. You can use name, and you get the value of the name of the note itself. So the note accepts various methods, like transposition, for instance, or I mean, again, there is a list of all the possible methods that you can use, apply to the note object. Here, if we transpose by 5 semitones, our note from 1 becomes a 6, and it stays in the same octave and the same duration. So as an exercise, if you want, you can use, you can expedient, I mean, kind of do some hands-on experience on inputting different notes with different durations and different octaves, so that you can see how this object deals with this primitive. Now, if you want to put together many notes, then we use this note sec object. The note sec object accepts a list of primitives, either notes or rests. So it's basically a container for note and rest primitives. And here you see an example. We have a sequence where I have a note C 0, a rest of unit 1, and then another note C# after that. Now, here it becomes very useful to have a way of displaying the notes. And there is this helper function, display notes, that allows you to display either individual notes or sequences of notes in a stuff notation. So here, for instance, I'm inputting a note, C, a rest of a quarter, and then a C# of an octave. And here is the result. Same thing, you can actually use list comprehension in the note sec. So for instance, here we are automatically generating a whole tone scale and displaying it using the display note function. NoteSec accepts many different methods, so you can operate on the sequences, again using transposition, inversion, retrograde, and so on. You can see all the list of the methods in the PowerPoint of the lecture. So as an exercise, again, hands-on experience, you can try to generate a few sequences of notes and operate on them with the available methods. And maybe you can try to generate simple melodies.